Algebra 1, Lesson 14, Determining the Theoretical Probability of an Event. We're going to cover this at length as we get into it a little bit later. You're going to see how we figure probability, but I'm just going to verbally explain it right here, right now, is that probability is the number of desired outcomes over the number of total outcomes. All right, hold on, give me a second. All right, so let me say it again, is that probability is the number of desired outcomes over the number of total possible outcomes, and then we reduce that fraction. Okay, we'll see that played out here in a little bit. But it says here that a same space, make sure I've actually, sometimes I have typos and things like that. I think that should be sample space. Okay, lesson 14, a sample space. This is whenever my fingers get... A sample space is the set of all possible outcomes of an event. For example, a toss of a fair coin has two equally likely outcomes. So if we're looking for the total number of outcomes for flipping a coin, that total would be 2, right? The two possible outcomes are heads and tails. That's the sample space, okay? Flipping a coin's pretty easy event to kind of look at. If I can get that out of my way. A simple event is an event having only one outcome. For example, the probability of tossing a coin and it landing on heads is 1/2 because the desired outcome is heads. That's one outcome, okay? Over two possible outcomes. So the probability is 1/2. We can write that off as a decimal of 0.5. We can write that off as a percent as 50%. Does all of that make sense up to this point? Okay, so we know how to find probability. The reason that I make kind of a big deal over you understanding what goes in the numerator and what goes in the denominator is because later on you're going to learn about things like odds. Odds is a totally different type of thing. When you talk about odds, that's different than probability. We're only talking about probability today. All right, the theoretical probability of an outcome is found by analyzing a situation in which all outcomes are equally likely, and then finding the ratio of favorable outcomes to all possible outcomes. Okay? All right, so there's your, I don't know, there's your explanation, there's your fraction. Number of favorable outcomes over total number of outcomes is going to give us probability. Okay? Odds is different. Odds is number of favorable outcomes over the number of unfavorable outcomes. Okay? So, you know, different places use odds than probability. They don't mean the same thing. They're not different words for the same thing. All right, a complement of an event. Complement of an event, although complement sounds like a nice thing, it actually means the opposite of what it is that you want, which is typically, when we think about it that way, is not a nice thing. So a complement of an event is a set of all outcomes of an experiment that are not in a given event. For example, if heads is the desired event, when tossing a coin, tails is the complement of that event. It's the other thing that could happen, okay? The thing that we're not looking for. The sum of an event and its complement should equal 1. Remember that if I'm flipping a coin, I have two possibilities, right? One heads, one tails. I have heads is my desired event, right? Tails is my complement event. 1 plus 1 is 2. 2 divided by 2 is 1. Okay? So the probability of an event plus the probability of not an event should equal 1. Okay? It's a little confusing, but I kind of hope we pick up on it. Chance-like probability is the likelihood of an event occurring, so it's somewhat similar, but it's not the same as odds. All right, so from here, let's look at some probability situations. Okay? Here we've got an experiment. It consists of spinning a spinner. All outcomes are just as equally as likely. Notice that 1, 2, 3, 4, 5, our little pie pieces, our little pie wedges are all the same size. Okay? What is the probability that spinning the spinner will land on 3? We want to express this as a fraction in simplest form. Okay, so as a fraction, why is this not? Give me the marker. Well, that's weird. Everything is... Okay, well, evidently I can't write on my board right now. So we're going to handle this verbally. What number goes on top of my probability fraction? What? 1. Why 1? Because there's only 1, 3. So the number of desired outcomes is only 1. All right. What goes on the bottom, Mia? 5. Why 5? Because there's 5 total. Okay. So our reduced fraction should be 1/5 or C. Okay. All right. Same type of situation, but we might look for something else. What is the probability that the spinner will land on an even number? Okay, Caden, what should go in my numerator? 2. Why 2? 2 even numbers. What should go on the bottom? 5. Why 5? Okay, because there's 5. So, all right, so we have 2/5. Does that reduce? No, it does not reduce. All right, so we should get 2/5. All right? I don't know. It's just, now we look at something that looks a little bit more complicated. I'm sure there's a simple explanation for why it's not letting me do what I need to do, and it probably has something to do with me, but in any case, it won't let me write on it. All right, here we have an experiment consists of rolling 2 fair number cubes. The diagram shows the sample space of all equally likely outcomes. What's the probability that the total shown on both number cubes is 9? Write your answer as a fraction in simplest form. All right, well, let's look at this. This is what they're showing me here are all the possible outcomes, right? Okay. How many outcomes are there? Well, we could do that by just simply length times width, right? 1, 2, 3, 4, 5, 6 down the left-hand side. 1, 2, 3, 4, 5, 6 down the bottom. How many different possibilities are there? 36. Where would I put that number on my probability fraction? On the bottom, in the denominator. All right. What am I looking for at this point, though, to go in my desired or numerator section? Anybody know? What am I looking for in all of this? The number, the sets that equal 9. Well, 1 and 1, 1 and 3 probably isn't going to be anything with a 1, is it? Because the highest number on a number cube is 6, and 1 plus 6 isn't going to get me there, right? All right. Is 2 plus 6 going to get me there? All right, so I can ignore the top 2 rows, correct? All right. We come down here, 3 plus 6 is 9, so I've got this one, right? Okay. 4 plus 5 is 9. Okay, that'll work. It's got to equal 9. Okay, am I missing anything? Okay, we got 3 and 6. We got 4 and 5. Yeah, 5 and 4. And the other 6 and the other 3, right? So 1, 2, 3, 4. 4 out of 36. But 4 out of 36 should reduce, right? 1/9 is correct. So do we see how we're going about that? It looks really complicated. It looks like a whole lot of information, but we can still easily solve that, right? Okay. All right, this is a little similar, okay? It's all of the same dice, all of the same kind of outcomes, but we're looking for something else. On both number cubes, what's the probability that the number shown is less than or equal to 8? Okay, well, we know that there's 36. All right, so we want anything that's less than or up to 8. All right, well, this whole column would work, right? Okay, because 1 plus 7. Let's see. And the whole second column would work, right? Okay, because we can be equal to 8. All right, then, all right, so we've got first column, second column, but we can only take the third column down to 3 plus 5, right? All right, so that gives me that. And then 4 plus 4. And then 5 plus 3. Hold on, 4, 4. Okay, 6, 2. All right, so we've got 6, and 6 is 12. 12 plus what, 7? Or sorry, 5. 12 plus 5 is 17. 17 plus 4, 21. 21 plus 3, 24. 24 plus 2, 26 over 36, right? What can it reduce to? 26 over 36. Can I divide them by what? 26? Can divide by 2. What's 26 over 26 divided by 2 is 13. 36 divided by 2 is 18. Can I reduce 13 eighteenths? No. Okay, so I get D as an answer. All right. Number 5, a carnival has a duck pond booth. You guys ever see these duck pond things where they drop all the little yellow ducks? Okay, you choose a rubber duck at random, mark on the bottom of the duck, tells you whether you won a small, medium, or large prize, or no prize at all. There's 65 ducks floating in the pond. There's 3 ducks marked as large prize winners, 13 ducks marked as medium prize winners, 21 ducks marked as small prize winners. Find a probability of winning a medium prize at the duck pond. All right, so what number should go on the bottom? 65. What number should go on top? All right, so what's 13 divided by 65? Give your answer as a decimal to the nearest thousandth. .2, and it probably would be 0, 0. So B is my answer on that. Are we understanding probability now? Okay. All right, number 6. Number 6, if a number cube is labeled 1 through 6, it's rolled. What's the probability that the roll will produce a number less than 5? Less than 5. How many numbers are less than 5? 4. 5 is not less than 5, right? So it would be 4 over 6, right? So 2/3. So I have a 2 in 3 chance of getting a number less than 5. All right. Let's see. What time are we out of here today? 9:31. Right, 9:31. So yeah, I feel like everybody's kind of getting real antsy, wanting to put everything away. We're not quite ready to put things away yet. Okay, let's answer one more question. Ooh, that's a pretty long one. Let's answer number 8. In a bag, there are 10 tiles numbered as follows: 1, 1, 2, 2, 2, 3, 4, 4, 4, and 4. The tile is randomly chosen from the bag. What's the probability of drawing a tile with a number greater than 1? Well, how many tiles were there? 10. So where does that number go? I've heard a mixed. It should be on the bottom, right? Total goes on the bottom. All right. How many of those are greater? 8 of them are greater than 10. Okay. 8 of them are greater than 10. So we can represent this a lot of different ways. Let's represent it as a fraction. What is the reduced fraction for that? 8/10 is what? 4/5. Can anybody tell me what the decimal is for that? 0.8. And what is the percentage of that? 80%. Very good. All right, do we feel like we're in pretty good shape? We could start working on our homework now. Okay, I'll let you guys do that.